Are you able to hear? Am I audible, Durgarao?
Yes, sir.
Okay.
Sir,
Yes. So whom am I talking to?
I am Gomadi, sir, from NPTEL.
Gomati. Okay.
Yes.
கேக்குறதா உங்களுக்கு?
Yes, sir. கேக்குது sir.
இது வரைக்கும் அந்த ரெஸ்பான்ஸ் ஷீட்ல யாருமே क्वेश्चन ஃபில் பண்ணல.
ஆமா சார்.
அதுக்கு என்ன அர்த்தம்?
துர்காராவ் கேட்டிருக்கேன் சார் சொல்லுவார்.
அதான் அது
क्वेश्चन எதுவும் வரல அப்படின்னு சொல்லிட்டு இருந்தாரு துர்காராவ்.
இதுக்கு ஒண்ணு துர்காராவ் இன்னும் ஹலோ சொல்ல காணுமே. அவர் கேக்குறதா இல்லையா? நான்
இந்த ஒரு நிமிஷம் சார், அவரு ஷீட் செக் பண்ணிட்டு இருக்காரு என்னன்னு தெரியல, நான் கால் பண்ணிட்டு இருக்கேன் சார்.
சரி. So I'm also checking on YouTube. I don't see any questions.
Hello, sir.
Yes.
Hello.
Yes, Durgarao. Are you able to hear me?
Hello, sir. Can you hear me, sir?
Yes, I can hear you, Durgarao. Can you hear me? Prem, am I audible?
Hello.
I'm able to hear you. So, Durgarao, are you able to hear me? Why is so, Durgarao, can you answer? Can you respond, please? Prem, can you hear? Or Gomati, am I audible? Sheesh.
Sir?
Am I audible?
Yes, sir. Durga Rao audio problem, sir. அதனால நீங்க பேசுறது கேட்கல அப்படின்னு சொல்லிட்டு இருக்காரு. திரும்ப ஜாயின் பண்றாராம் சார்.
சரி. இப்போ இந்த யூடியூப் chatல
Yes, sir.
Okay. I don't know. So they're saying, of course, they can hear me. I'm wondering why I cannot just type anything there. Usually, I should be able to type an answer also. Okay. So there is a question from Pallavi. They have exam on 23rd of April. So Gomati, that's correct, right? So the exam is on the 23rd of April, 2 days later.
Yes, sir.
So she is anxious about the pattern. And will there be any questions out of the syllabus? Obviously, we will not ask anything outside the syllabus. That I think is ruled out. Well, if they want to know the pattern, I think, Gomati, we have already given them the pattern, haven't we? The format of questions have been told to them, right? Okay, so I briefly lost connection. I'm back. So in Gomati, are you able to hear me?
Yes, sir.
So my question was whether we have already told them the format of the exam, meaning what type of questions, whether it is MCQ or not. Have we informed?
Yes, sir.
Because this particular student is asking, Pallavi, what is the format? Well, the format is going to be MCQ or numerical answer type. In terms of tips, what is there? You just have to solve your assignments on your own, listen to the lectures. And one thing I can tell you, that you want to, given a question, first find out the concept associated with that question. Don't search for formulae. Typically, we are used to thinking of some formula that is very helpful for a given question. But instead of that, I think you should ask, what are the concepts relevant to this given question? And then ask how those concepts have to be applied. So, for example, you may have a question on autocorrelation, or it may be on stationarity. I mean, these are all standard concepts. So you will have to first connect the question with the concept, and then the concept to application. How do you apply that concept here? Because with the given, for a given concept, there may be some definitions or there may be some formulae and so on. Ultimately, it will come to applying some definition or a formula. But before you do that, you will have to go through these basic steps in order to use the correct definition or the correct concept for the question. If you do that, typically you should be able to answer any question. Okay, that's the most important thing that people miss out on. I mean, they look at a question and they are thinking what to do. Work your way backwards. Always start with what the question is asking you to do. If the question is asking you to, for example, let's say find the autocovariance, just as an example. Don't now think that there will be such a question. Maybe they may not, but I'm just giving you an example. If the question is asking you to calculate the autocovariance function, let's say given some model, AR model or an MA model, then you should start with that. You should ask, what is the definition of autocovariance function? That definition you should know. Obviously, it's a very central concept to time series analysis. So you should know the theoretical definition of autocovariance function and also the expression for sample the estimate, that is the estimate of ACVF, depending on the question that is being asked. So first you should resolve whether the question is asking you to calculate theoretical ACF or sample ACF. If it is theoretical ACF, then look up the definition even in your mind. And that's where you have the expectation averaging across the population. The standard expectation of VK minus V bar times VKL minus V bar, that's your ACVF for the population or the theoretical ACVF. And then you ask, given the model, how do I use that information along with this definition to answer? That's it. But of course, this means that you should have practiced a few questions like that, where a model is given and you should be able to calculate the theoretical ACVF. That practice will come very handy. This is a very standard approach and a very powerful approach to solving any problem. Find out, work your way backwards, find out the concepts that are relevant to that question. Don't scan all over your brain on how to solve, and so on. First, find out the concept, and then associated with that concept, there may be many definitions or many other formulae and so on. Figure out what the question is asking, use that particular definition, and then ask, how is the information given in the question useful to me? This is so that you will get by practice. How do you use the information? Sometimes you may have to think a bit more. It may not be so obvious, but it doesn't mean that you have to sit down and do some tapasya for 10 years or something like that. If you just think through in a minute, you will get the idea. Okay. So, good evening to Bharat and Harita. Okay, any other questions? So I'm also looking forward to some technical questions if there are any. Yeah, one thing that can be very useful is just in your mind mentally working out the assignments on your own. You may not have had a chance to solve all the assignments or all the questions of a given assignment. So just mentally work out and have the solutions also ready next to you so that you can compare whether your thinking is correct or not. With the marks of, yeah, of course, it will be counted. I think we have announced that, Gomati. Are you online, Gomati? Yes. I mean, I don't know. I'm yet to hear from Gomati, but yes, the marks of weekly assignments will be counted. We have best 8 of, we picked the best 8 of the 12 assignments. Prem, isn't that the case?
Yes, sir. In 12, this Durgarao, sir. In 12-week assignment, we will take best of 8 assignments out of 12, sir. For the final exam score, in that best, we will take 25% of scores, sir.
Okay, thanks, Durgarao.
Okay, sir.
Okay, any other questions from Harita? His assignment will become. I don't know what that question means. Obviously, we will not take a question ditto from the assignment and put it up in the exam. That is not going to happen. But there will be questions similar. Some of the questions may look similar to the ones that you've seen in the assignment. So it's like when you build a model in data science, there is a training data set, there is a test data set. Your assignment data is a training data. When we set up our test data, one of the standard guidelines in data analysis is to choose some of the test data points to look similar to the ones that are there in the training data. And the remaining will look different. So the same applies here as well. Some of the questions in the exam will look similar to the ones in assignment, but we cannot say this many and so on. Okay, good. Bharat, go ahead. So I see many people work in machine learning. Correct. So what's your question? Okay. It's a very good question. If you ask me whether it's a good approach, it is not. That is just, kind of a trial and error approach, hit and try. Unfortunately, a lot of times people are only trying out things one after the other and see which one works. It should not be that way at all. Not at all. And that is because I think either they are not trained in that way in the courses that they have taken. They have to first be trained to think that way. If they are not trained, it's like model. If the model is not trained properly, you cannot expect it to do wonders. So anyone who is in data science as a profession, pursuing data science profession, first should be trained to think that way, that for a given problem, first of all, state the problem very clearly, list out all the assumptions that are being made. What is the setting, whether it's a stochastic setting, deterministic, mixed, whether you're dealing with a linear process, non-linear. State as many things as you know very clearly to know the setting and the framework, the boundaries of your work. And then you also have to clearly state the problem that you want to solve. And then pick the right approach. Okay, but unfortunately, and then that has to be done in a very systematic way. So as an example, very recently we published a work on analysis of seismic noise. Now, seismic noise is a stochastic signal that, well, we are making that assumption. So first thing is, how do we know it is stochastic? Well, from first principles, I mean, there is no first principles model that you can develop to predict the seismic noise, meaning the noise that is recorded of the earth underground by a seismograph or a seismometer. Basically, Earth's activity in that area. So it's not possible to build a model to predict it. So we have to start from that point. When I'm assuming something being random, I have to first justify, as I've said in the course, why I am thinking of any signal as random. Simply stating it as random is not enough. I have to be very clear in my mind, why have I assumed it to be unpredictable? Accurately not predictable. And from there, you go on to, if you want to build now a time series model for seismic noise, then you will have to go through the standard systematic procedure. You'll have to first check for stationarity, then you'll have to check for predictability, then you'll have to maybe sometimes test for linearity of the time series model, or if you don't test also, you start with a linear time series model and so on. So, and then you have to follow the prescribed systematic procedure for developing a time series model. Now, this is as far as time series modeling is concerned. The same applies to developing any model, whether it is for classification or whether it is for regression. Everywhere, you will have to follow a very systematic procedure. And if you don't follow systematic procedure, what happens is either you will end up, spending a lot more time than needed, number one. Two, you may end up with a suboptimal model or a model that is not suited for that given process. And three, you will not know when your model will work. I mean, under what assumptions your model will work, and what happens when the assumptions that you have made fail. So all these things we will not be able to answer. So essentially, when your model fails, you will be lost and you will not be able to fix it easily. And that is why people go for trial and error. If one model doesn't work, they switch out another model. Then they switch out another model. But that is not the way to go about doing it. So in short, you'll have to state your assumptions, define your problem statement, make certain important statements about the uncertainties, nature of the process that you have assumed, put in any domain knowledge that you know. All of that has to be done. Okay, so hopefully that addresses some, if not all, of the concerns that Bharat has. Okay, now next is, Neha, good evening. Nehal, very good evening. Mohammed Nihal, sorry. Good evening. How many minimum marks for getting NPTEL certificate from proctored exam? Durgarao, would you like to answer that question?
Sure, sir, definitely. For getting the certificate, there is the two criteria is there. One is a assignment criteria, one is a final exam criteria. For assignments, we take 25% marks for the final exam. For exam is out of 100. In out of 100, we can take 75% for the final score calculation. So in minimum, for a assignment score, you get in a assignment you should get 10 marks. In final exam, you should get 30 marks. Then total 40 marks. Then only you should get this certificate. If you're not satisfied any one criteria, you don't get any certificate in the particular course.
Okay. Okay, so hopefully that answered the question by NC. I don't know the name actually. question which is outside the scope of this course. For multivariate analysis, how to detect anomalies and also univariate. Yeah, we don't talk about anomaly detection in this course, but nevertheless, I'll try to answer. They give you the general idea. First, you have to define what you mean by an anomaly. This is again going back to what I said earlier in response to Bharat's question. You should not get into any anomaly detection before you define what an anomaly is. What is anomaly for you? An anomaly for in one domain may not, that definition of anomaly in one domain may not be applicable to another domain. Okay. So for example, if you take ECG, the anomaly in an ECG will be different from an anomaly in an industry operation. Normally in ECG would be that a new frequency appears or there is some pattern change in the ECG. It has a regularity to it. It has certain frequencies. Whereas the the anomaly in a process industry would be that there is a certain band of values that you see if the process is operating well for the measurements, and maybe and any excursion outside that band would be flagged as an anomaly. So the anomaly has to be first defined upfront, qualitatively, and then you will have to come up with a statistical definition or a mathematical definition of the anomaly. And then you should set up a detection procedure. So suppose I am looking at, let us say, a standard example in vibration machinery. Right? So let us say you're driving a two-wheeler and or any vehicle, but let's take the two-wheeler as an example. When we are driving, we are listening to the sound coming from the vehicle. So that's a time series for us. In our mind, we have a model. When we buy it, we know that, let us say we are assured and we know that the vehicle is in good, healthy condition. So whatever noise that comes from the vehicle, assuming that every vehicle makes some minimal noise, that will be the template for us. So that is a working template for us, that when the vehicle is in healthy condition, the sound time series that is coming out from the vehicle when we are driving it has to be within that amplitude and within that frequency. Our brain is doing some kind of a Fourier analysis. So it is listening to the amplitude and it is also analyze the frequencies. We may not be able to write down the numbers for the frequencies, but it has done some spectral analysis. Now, as days roll by, whenever we are driving, doesn't matter even if it is the 50th time in a day, our sensors, our ears are listening, and maybe we are also feeling the vibration from the vehicle, and all of this is continuously processed in the brain. And if you were to think how our brain is detecting if something is wrong, it is basically comparing two things at least. One is the amplitude of the sound, and two, in appearance for any new frequencies. This is usually the case with vibration machinery. So this is called a spectral method, or you can say amplitude-based method, but mostly it's a spectral method for anomaly detection. Likewise, in some other approach, it may be something else, but the general procedure for anomaly detection is you have to first define qualitatively what an anomaly is, then put it in mathematical terms, whether in terms of in terms of the frequencies that you expect to see under normal conditions, normal operating conditions, or the amplitude or some other statistical property. It could be mean, it could be variance, or it could be any other statistical property if it is univariate. And once you define what is your normal operating condition, then, or once you define the anomaly that you are searching for, then you will have to think of now a method for detecting that. So if you are estimating that from data, so if you are looking for new frequencies, then a method would be to estimate the power spectral density from the recent window of data that you are getting in. So assuming that you're getting streaming data, and keep searching for peaks in the power spectral density. If there is a significant peak at a new frequency, then you flag an anomaly, and so on. So this is, of course, I've given you one example of anomaly detection for univariate. For multivariate, it's a different story. You will not only analyze individual variables, but you will also test for the breakdown of any relationship between multiple variables. So there is a broad literature on this. Typically, anomalies are also called as faults in process systems engineering literature, and there is a huge literature amount of body of literature on fault detection. You can look up, but I would certainly recommend that you look up the domain. So if you're dealing with biomedical data, you should search through the biomedical data, because the type of anomalies that you see in healthcare applications or in health related matters may not be the same anomalies that you will see in process, industrial processes. And you may see a different anomaly in agricultural process. So look up the domain and see if there are any specialized methods for it. Okay. Any other question? Can you apply decompose? You mean time series decomposition? Yeah, you can. Yeah, but a lot of these those techniques that if I have talked about in the course, like STL and LOS and all those methods, they will assume that you have a seasonal component. See, basically, if it is only a trend and the rest of it is like a stationary signal, you don't need any major decomposition. You just fit a linear model. Sorry, you fit a polynomial model to extract the deterministic or the deterministic trend, and then the rest of it is stationary part to which you can fit an ARMA model. So that is why there is no special decomposition method. It is not mandatory. Those methods work on assuming that they assume that you have a seasonal component to work with, because they do some kind of averaging and local averaging and so on. But if you ask in principle, should there be a seasonal component? No, for decomposition. You can have a trend and a stationary component alone. But it's not challenging. That's why there is no particular method for you. The simple procedure is, if there's a deterministic trend, simply fit a polynomial or a spline and extract the deterministic trend. The rest of it you can test for stationarity. But the methods, the routines in R, like STL and decompose, they are built assuming there is a seasonality. So you cannot use those methods on data that have only a trend and stationary component. They necessarily assume that there is a seasonal component. Any other question? How to reach me? You can email. You can email me. You have my email address, no? Today you can find the email address of anyone on the web. You can simply write to me at arunkt@iitm.ac.in. Sure, you can always write. In fact, you should post on the forum, because then others can also benefit. Sometimes I feel disappointed that on the forum I hardly see any questions. Yeah, I understand. But what I'm saying is, if you are comfortable with asking the questions on the forum, I would encourage you to do so, because everyone else can also benefit. Parameter estimation to NPTEL. Yes, there are. Mostly it may be offered under Swayamprabha, but yes, I know parameter and state estimation should be brought to NPTEL. It's a very, very important course. I will certainly consider that seriously. The course is being taught already in the when this recording of time series was being done. At that time, the course was not being offered, but now over the last 2 years, the course on parameter and state estimation is being offered at IIT Madras. So we'll just have to see how to bring that to NPTEL. In fact, next semester again, I'm teaching that course. Okay, so Saikiran asks if it is mandatory for the data to be collected. No, but all the concepts that you have learned in this course assumes that the data is collected at regular intervals. There are many applications in which the data is collected at irregular intervals, but that doesn't mean that whatever you have learned in this course goes useless. You need, so there are many ways of handling irregular data. One way is to reconstruct the missing data points and then use the techniques that we have learned in this course. The other way is to, the concepts that you have learned, namely autocorrelation, spectral density, the notion of station, all those apply to irregular data as well. The other way of handling irregular data is to tailor the estimate. See, essentially it has got to do with estimation. One approach, as I said, is to reconstruct the missing data and then apply, then estimate, then apply all the methods that you have learned. The other approach is to tailor the estimation approaches itself to handling irregular data. That's a slightly advanced concept, but you will find, for example, in astronomical processes related to astronomy, a lot of times the data is collected at irregular intervals. So there is quite a bit of extension of these methods to handling that. then you may find in processes where event-based sampling occurs. So in those cases, all in such process, in such domain or literature also, you will find extensions of these methods. Yeah, so as I said, apart from imputing, there are methods that will directly handle the irregular data. For example, today you have what is known as compressive sensing technology, which deals with data collected at random points in time or random points in space, where you don't necessarily impute anything. You can carry out your analysis directly with that given data. And there's a huge, that's now considered one of the hottest areas today in signal processing. We have also been working on that. You can refer to some of the papers, but of course, there's a lot of literature on that. So you should search for compressive sensing and sparse optimization and so on, where people make analyze data that has been collected at random points in space or in time. Of course, some of those methods may involve imputing, but there are methods again within the compressive sensing umbrella that do not impute. It may be difficult to talk about the technical nature of those methods here, but I'm just giving you some keywords to search for. Oh, sure, Bharat. Yeah, well, it's I don't know what you mean by paid course. Well, the course is actually now going to be taught in person. The last 2 years, it was taught online. But if you want to come to campus and take the course, yes, you are most welcome. IIT Madras allows external people to register for a course by paying, I think, some money. I'll have to find out the exact procedure. But you should be able to. There is a certain procedure. And with regards to when I will be able to bring that course to NPTEL or Swayam Prabha, yeah, I will send out, do email me so that I can keep you informed. How to join which course, Sai Kiran? Are you referring to the course on parameter and state estimation? Currently, it is a campus course. It's a semester course here. And you will have to come to the campus next semester to be able to attend the course. Register for it and attend that course. Yeah, the information may not be updated on the website, but you can email me so that I can keep you informed. I have been having plans of posting all the recorded lectures of the course informally on YouTube for the benefit of community at large, but they have to be kind of screened and edited to avoid irrelevant portions in each video. That way, at least a first cut of the course is available for many curious learners. I'll see if I can do that. Then I can post it on my YouTube channel, at least to begin with, so that you get 80 to 90% of the course. Which video did you find, Sai Kiran? So I don't know if Sai Kiran. So are you referring to time series analysis, or are you referring to parameter and state estimation? I don't know. Okay. So then, as I understand, Sai Kiran, you are not a registered learner of this applied time series analysis. That you can register on NPTEL whenever the course is offered. You can. Any online resources for referring to which literature, Bharat? If you're asking if there are any online resources to accessing papers, a lot of journals are open access today. If you're only interested in searching the literature, there are some very good websites like Web of Science and Scopus and Google Scholar and so on. But if you want access to the papers, then for paid journals, unfortunately, you will have to subscribe, or your institution has to subscribe. But fortunately, now many journals are turning to open access. So you should be able to freely access a lot of the literature that's coming up. And nowadays, there is this concept also that the preprints of any journal paper are available on archive, arxiv.org or bioarchive and so on. And you should be able to at least get a preprint version, which will not differ much from the published version. So you will have access to all those results as well. Well, I think questions now pertaining to resampling and so on is, I think, outside the scope of this discussion, especially you're referring to categorical data. I think that has to be addressed separately. It's hard to answer in this forum right now. I would urge you to refer to the books on bootstrapping methods and first learn how resampling is done for numerical data. Then it may be a matter of mapping the categorical data to numerical data and then applying the resampling method. That's a quick answer that I can give. Any other technical questions? So as I said, Sai Kiran, you can go to NPTEL website and see if this particular course is offered in the next cycle. And if it is, then you enroll yourself. Typically, we have been offering this course once a year in this Jan to April. But if NPTEL decides to offer it again in July, an announcement will be made. Durgarao, you want to say anything on that? Okay, so it looks like Durgarao is not able to hear. But yeah, so just keep looking up on the MOOC, NPTEL MOOC. They have from time to time announcements of the courses being offered.
Sir, I'm the line, sir. Sir, for our course, we are after the semester, January semester, sir.
Your voice is breaking, at least for me.
Hi, sir. I will, for this course, we offer every semester in January to April semester.
But okay, so when should the student again refer to the NPTEL website?
Next January 2023, sir.
Yeah, before that, right? I mean, sometime in November.
Yes, sir. We open into November, sir. November will be open to enrollment, sir.
Right.
Yes, sir.
Yeah, good, Bharat. Thank you. But feel free to write to me if you have any questions or post on the forum. Okay, so it looks like there are no more technical questions. We'll wait for a couple of minutes and then maybe close the meeting. And people who wanted to ask questions and have missed out on the meeting can always post questions on the forum. Okay, so I think if there are no further questions, we can adjourn for today. Thank you everyone for participating. And good luck to all my students for the exam. Do well, think well. You should be able to do, you should be able to perform very well. Okay, so Durgarao, maybe we can close the session.
Yes, sir.
Gomanti?
Yes, sir.
Yeah, since there are no further questions and there are no questions in the response sheet either, shall we close then?
Yes, sir.
Okay. So thank you very much to everyone for joining the session today. And thanks to NPTEL for coordinating this. Thanks, Gomanti and Durga Rao. And yeah, Prem and I wish you good luck and we'll keep in touch. Thank you. Good night. I think, Gomanti, we can close the session.
Yes, sir.